Hello and welcome to our lesson on radicals, dividing radical numbers. Okay, there are some rules when we do this division. First, in order to divide a radical expression, you need to divide like terms. And remember, like terms, any whole numbers are considered to be like terms to each other, and any radicands are considered to be like terms to each other. Radicands and whole numbers are not like terms to each other. They're totally separate from each other. So a quick review, you have a whole number here, your index is there. You've got a radicand and a radical sign. All the radicands, whatever they are, 6, 4, 22, those are all like terms to each other, and then whole numbers are separately like terms to other whole numbers. They can't combine. When we divide radicals, first you cannot divide a radical. Why? It's kind of like exponents. You must multiply the entire fraction by the denominator. You never really divide radicals, you multiply them. Then step 2, you treat the problem as a regular multiplication problem, and you simplify any remaining radicands. So first thing that we're going to do, step 1, you cannot divide them, so you have to multiply the entire problem by the denominator. So you're going to take the first one and you're going to multiply it by 6 radical 3 on the denominator. Remember with fractions you have to keep them equivalent, so whatever you do to the bottom you also have to do to the top. And now you have to go ahead and treat it like a regular multiplication problem. So we've got our multiply by 6 radical 3 on both top and bottom. When we do that, whole numbers multiply to whole numbers. Radicals multiply to radicals. So you've got 6 times 6. So on the denominator, you've got 36. And then you have radical 3 times radical 3. If you remember, when you multiply radicals, you just multiply the numbers like normal. So 3 times 3 is 9. Then on the top, you have a negative 12 times 6. So you're going to get a negative number, and it's going to be negative 72. And then you're going to multiply radical 2 times radical 3, so you're going to get radical 6. And we're not done yet, because if you notice, the whole reason why we did that multiplying by the denominator, look what happened. The square root of 9 should look really familiar. That's a perfect square. By doing this multiplication, we just created a perfect square on the bottom. We can get rid of the square root now, because the square root of 9 is really 3. So we can rewrite this. We've got negative 72 radical 6 on the numerator. Then we're going to divide it by 36. Notice how they're touching? That really means multiplying. And instead of the square root of 9, we're going to simplify it to 3. So now you have to multiply out the denominator. You're going to end up with negative 72 radical 6 over 36 times 3, which is 108. So far, so good. Now, once we got that, we got 72 negative radical 6, and then on the bottom we had 108. We can simplify. You have to simplify radicals to radicals. There's only this one radical here, so you leave it alone. It's fully reduced because it's 2 times 3 and there's no pairs to take out. However, look at your whole numbers. It's like a regular fraction. You just go ahead and reduce it. So let's take 72 and we're going to divide it by 2. And then on the bottom we're going to take 108 and we're also going to divide it by 2. So, if we're going to divide 72 by 2, old school division, that's going to go in 3 times. That's 6 and 12. So that's 6. So on the very top we have 36, and that's a negative number. Radical 6, because you don't divide the radicals. We're only focusing on the whole numbers. And then if we divide by 2 on the bottom, we're going to get 54. And hang on, these aren't completely reduced yet. We can still reduce them again. 2 goes into both those numbers. So if we take 36 and we're going to divide them by 2, and then on the bottom we're going to take 54 and divide it by 2. If you notice though, instead of keep reducing by 2's, 36 and 54 are both divisible by 6. These are both factors of 6. So 36 divided by 6 is 6. We still have our radical 6, and it's still a negative number over 54 divided by 6 is 9. We can reduce one more time. Those are divisible by 3. So negative 6 divided by 3 is negative 2. And you still have your radical 6. And then 9 divided by 3 is 3. So right here is your final answer. So when we take negative 12 radical 2 and divide it by 6 radical 3, we get negative 2 radical 6 over 3. Seemed like a lot. Let's try another one. Remember, first step, you're going to multiply the entire fraction by whatever's in the denominator. Multiply whole numbers. Those are like terms. So 3 times 3 is going to be 9. So you have 9 on the denominator. Now 4 times 4 is 16, and it's still under the radical sign. And then up top, you're going to have 15 times 3. And 15 times 3 is 45. And then 9 times 4 is 36. See why we keep doing this? Why we're multiplying it by the exact same number? Because look what happens. We create a perfect square every time so we can get rid of the radical sign. So on the bottom, you're going to have 9, and they're touching, so they're being multiplied together, times 4. On the top, look what happened. Just by great coincidence, this is also a perfect square. So we have 6, and it's being multiplied by 45. So now we got rid of all our radicals, and we can just go ahead and multiply. So 45 times 6 is 270, and 9 times 4 is 36. Now, it just so happens that 18 goes into both of these, so we're going to reduce the fraction by 18. And when we do that, we're going to end up with 15 over 2 as our final answer. So 15 radical 9 divided by 3 radical 4 is actually 15 over 2, or if you wanted to write it as decimal, 7.5. Let's try one more. Okay, here's your denominator. So you're going to multiply both the numerator and the denominator by the denominator, and take that negative sign with it as well. Anything that's on the denominator, you just multiply the exact same thing. Alright, we did it on the bottom. Now we have to do it on the numerator. So we're going to multiply by negative 4.3 radical 8. And remember, the whole reason we're multiplying by another radical 8 is to cancel out the radical sign. Because when we do that, negative 4.3 times negative 4.3, you're going to get a positive number, and it's 18.49. And then 8 times 8 is 64. We just created a perfect square. So eventually we can get rid of that radical. Now in the numerator, you're going to get negative, because you have a negative times a positive number. You're going to get negative 21.5 radical 160. It's a big radical. So that means you're going to have to take this radical right here and factor tree it to break it down. And I know that it's going to be 16 times 10. And then I have 4 and 4. I have a pair. This is not going to break, so we have to keep that underneath the radical sign. So actually, on your numerator, you have negative 21.5 times that 4 that came out, and your radical 10. On the bottom, that's a perfect square, so you've got 18.49 times 8, because the square root of 64 is 8. Now when we go ahead and multiply all this lovely stuff out, we're going to end up with negative 86 radical 10 over positive 147.92. Now the radical 10 can't be reduced, but you can reduce the whole numbers. They're like terms, so we can bring them down. And if we go ahead and we divide them by 2, because they're both even numbers, so we can divide them both by 2, it's going to turn out to be still a negative 43 radical 10 over a positive 73.96. And that's going to be your final answer. So at the very end, it was just a lot of regular division reducing. Okay, a quick review. Radicals are never truly divided. We don't really ever divide them. We multiply them. We multiply the entire fraction by the denominator. Treat it as a regular multiplication of radicals after that, and be sure to simplify any remaining radicands and whole numbers just like we did. And that's it for our lesson on radicals, dividing radical numbers.